Hello guys, this is Dev and I am going to present to you a series of lecture on physics. You'll find these lectures helpful for NEET exam, JEE, main and advanced, and other engineering entrance exam which ask physics. So I'm going to cover physics, the whole syllabus, okay, in all of these videos. And you don't need to go anywhere, you don't need to spend your money on coaching institutes who teach you physics. I'm going to teach you right here, and I'll cover everything from start to end. So let's begin. So you see, this is the syllabus for physics. We have 20 topics and I'll cover each topic one by one. And right now I'm going to start with the very basics of physics, which starts from scalar and vector. Okay, so we begin by scalars. As we all know, scalar has a magnitude but not a direction. So some of the scalars are energy, work, time, speed. These are represented by the notational symbols only, E, W, T, V. On the other hand, vectors are the quantities which have both direction and magnitude. So these are quantities like force, velocity, displacement. These are represented by the notational symbol and an arrow of them, F, V, X. So I am going to explain the basics right now, and only some of it you need to know, not everything, because vector and scalar are too big and much of the part comes in mathematics. So I'll teach you only the part which is relevant for physics. So initially we can say the scalars follow properties like A plus B equal to B plus A. This is the commutative property. Also the associative property, A into B into C. Okay, or we can say A plus B plus C. This would be equal to A into B, or this would be equal to A into C, whichever way you want it. And this would be equal to A plus B plus C. This would be equal to A plus B plus C, and this would be equal to A plus C plus B. So in representing vectors, we can represent the vectors in a very much similar way the scalars are represented in a graph. For example, say x and y axis are there. I'm only taking two axes. So for example, a vector is given r equal to 3i plus 4j. How do you represent it? So you see, you mark 3 in the abscissa, 4 in the ordinate, you have 0.34, and you put a direction from this point O to point P. This OP is your R. For example, this vector would make an angle with the x-axis. Okay, so the vector can also be represented as mod R, cos theta I plus sin theta j, and this I is along x-axis and j is along y-axis. I and j are only directional vectors. They don't have any much significance except for directions. Okay, so and we calculate the magnitude of the vector in a similar way like Pythagoras theorem. This is 3 and this is 4 and this must be 5. Okay, so mod R must be 5. Alright, so we can say cos theta here in this triangle is 3 over 5, sin theta here is 4 over 5. So we substitute the value here. We have R equal to 5 into 3 by 5i plus 4 over 5j. 5 gets cancelled out and we are left with 3i plus 4j, which was the original vector. Okay, So R can be divided into its own components, Rx and Ry. And R2 has a unit vector along its own direction, which is the R cap. So R is written as R magnitude R cap. So the unit vector can be calculated as, so for example, in the previous example, R was 3i plus 4j. So we have here R magnitude would be equal to 5, and hence the unit vector would be 3i plus 4j by 5. We can easily see if this is the angle and this is 3 and this is 4. So 3 by 5 would be cos theta, because this would be 5, 3 by 5 would be cos theta, so cos theta I plus sin theta j. So we can separate the vectors into its own components along the angle it makes with any of the axes. Okay, so for example, if two vectors are to be equal, then for example A and B, they should be equal in magnitude as well as direction. So we can write it here as mod A equal to mod B, also directional A equal to directional B. This has to fulfill. Okay, this is different from collinearity, as for example A and B are parallel. Parallel does not mean equality. So here A would be equal to KB. This is the condition for vectors being parallel. We can say collinear, which is similar to being parallel, and this K would be equal to modulus A by B. So now we turn to addition of vectors. For example, how are two vectors added, A plus B? If these two are vectors, then we can say that A, if this is A, this is B. So we draw a parallelogram. We can see, since parallel, in the parallelogram the parallel sides are equal, so this would be B and this would be A. The resultant is always along the diagonal of the parallelogram, which is R, and hence R would be equal to A plus B. We can similarly see R equal to A plus B. Here the resultant is from tail of A to head of B. In the similar case, R would be equal to B plus A, where the resultant is from tail of B to the head of the A. Okay, so A plus B and B plus A are equal, and hence the commutative property of vector is followed. So vector is commutative. A plus B equal to B plus A. For example, adding three vectors, if we add three vectors, C, A, B, and for example this is C. So we take the resultant from tail of A to the head of the B, which is R1. Okay, and we take the next resultant, overall resultant is R2. So we have R1 equal to A plus B, and R2 would be equal to R1 plus C, which is equal to A plus B plus C. This is the net resultant R2. So this is the sum of all vectors. Okay, so now we turn to position vector. This is highly relevant for physics, as you will need to know what is position vector. So position vector is a position of the particle P from a reference point, which is O. Generally it is origin. So along all the three axes, it can be written as x, y, and z. So P would be written as xi plus yj plus zk. So for example, if this can be R1 and this can be R2. For example, this is O. So for example, P is x1, y1, z1, say, and O is x2, y2, z2. So what is the distance between the two? For example, if I ask what is OP, then you see direction of OP is from O to P. So this will be OP, and the triangle law will be applied like this. So R2 plus OP will be equal to R1. Here resultant will be R1. Okay, so we can say R2 plus OP would be equal to R1. So OP here would be equal to R1 minus R2, and OP would be equal to X1 minus X2I plus Y1 minus Y2J plus Z1 minus Z2K. Okay, and if I would have asked what is PO, PO would be like this, from P to O. So the triangle would be now R1 plus PO would be equal to R2. Now resultant would be R2. So R1 plus PO would be equal to R2, and hence PO would be equal to R2 minus R1, which is just the negative of OP. Okay. So you see vectors change when sign changes. Now we come to the dot product. Dot product between two vectors, for example, say this vector is A and this vector is B. The angle made between them is theta. So I'll have to find the dot product. Dot product here would be A dot B. Okay. So A dot B would be equal to modulus of A, modulus of B, and cos theta. It is always the cos of angle between them, and the angle is measured between their two tails. Okay, so it will be always cos of theta. So for example, if cos of theta has to be calculated, then A dot B would be equal to A dot B by modulus A modulus B. Say for example this is 0. Let us say the dot product is 0. Then that means cos theta would be equal to 0 and theta would be equal to pi by 2. This means the vectors are perpendicular, or another term for it is orthogonal. Perpendicularity or orthogonality. So say for example we have a vector A plus B. Now we have to find its square. So how do we find it? We take the dot product of A plus B. Okay, so this would entail A dot A plus B dot B plus twice A dot B plus twice B dot A. And another thing, A dot B would be equal to B dot A. There is no change when the vectors are, interchanged. Dot product remains the same when the vectors are interchanged. Okay. So this means A dot A would be equal to mod A, and this would be 0 because A would be parallel to only itself. So the angle between them would be 0. So this would be mod A square. This would be mod B square. This would be A dot B, and B dot A can be written as A dot B. So this would be equal to actually this is not 2, sorry, and this would be equal to twice of A dot B. So this is the answer. Dot product of self is taken. Okay, so say for example these three vectors are given, A, B and C. The question is, show that these vectors form a right triangle. How do we do it? We take the dot product of each vector. For example, A dot B. Now what would be A dot B? See, we multiply the individual, we take the dot product of the individual vector. Okay, 3i dot I, since I is parallel, and modulus of a unit vector is always 1. Okay, and this would entail I being parallel, so I dot I would be equal to mod I cos 0. This is 0, and since modulus of unit vector is 1, so this would be 1. Similarly J dot J, so this would be 3i dot I, which is 3, then 3i dot J. So you see I and J are perpendicular, so I dot J would be equal to mod I mod J cos 90. This would be equal to 0. So 3i dot I minus 0 plus 0. I dot K, I and K are again perpendicular. Then again 2j dot I, this is also 0. Then minus 2 minus 3. J dot J is 1, so minus 2 minus 3 is plus 6. And K dot K is also 1, so this would be plus 5. 3, 6, 9, 5, 14. So again we do A dot C. A dot C would be equal to, we just take I, J, J, K, K. We know that every other product will be 0. So 3 2s are 6, j means minus 2 and k minus 4. This would be equal to 4 minus 4. This is 0. So we have a dot c is 0. This means that vectors a and c are perpendicular. Since because vectors a and c are perpendicular, that means b must lie between the two. So we have this. This is a right triangle. So these vectors are forming a right triangle because a and c are perpendicular. Any one angle is 90, so the triangle is right angle. Okay. And I forgot to mention one thing, that a dot b would be equal to mod a mod b cos theta. This is always a scalar. So dot product is always a scalar. It can never be vector. Even with a plus b, we took the self of a plus b, and we have mod a square mod b square plus 2a dot b. Since a dot b is scalar, mod a and mod b square are both scalar, so this is a scalar quantity. Okay. So now we take the vector product. Vector product is very relevant in physics when we come to electric field and magnetic fields. So vector product is taken as, for example, there are two vectors a and b. Angle between them is theta. So we have a cross b. Now this vector product is again a vector. So this would be equal to mod a mod b sine theta, and this would be equal to, this would entail a unit vector n along the direction which is perpendicular to a and b. This is n. Okay. So for example, we have two unit vector I and j. So I cross j, you just put your right hand on the I and then curl your fingers towards j, and the point in which the thumb point along which thumb is directing would be k. So this would be k. So I cross j is k. Since I cross j would be equal to mod I mod j sine 90, and n is perpendicular to k, so we always write this as k. So this is equal to k. If it had been j cross I, then we would have put our right hand on j and then curl our fingers towards I, and then k would be down below. So this would be equal to minus k. Okay. Another thing, when two vectors are taken for cross product, this is also known as cross product. For example, a here would, if a here is axi, ayj and azk, and b here is bxi, byj and bzk. So there is another method of determinants, I, j and k. This is a standard formula you need to know. You don't need to go into depth because this is physics, not maths. Ax, ay, az, bx, by, bz. So we can solve this determinant as I, ax, bz, sorry, I, ay, bz. This would be ay, bz minus az, by minus j. This would be equal to ax, bz minus a z bx plus k, ax by minus ay bx. So this is the determinant method for vectors. Okay. So guys, I hope we have covered much of vectors. Now I am going to teach you differentiation. This is also very relevant in physics. You need to know the basis of this differentiation and how do we do it. You can memorize the formula. I am going to teach you concepts, okay, and take a few examples, because concepts are very important in these exams. You can memorize everything, you can do 100 examples, but concept learning is very difficult. So say y equal to function of x. Y varies with x. Okay. So let's say y equal to x square. So the graph of x square would be like this. Y would be positive for all x. Okay. Even if x is negative, y would be positive. For minus 2 it would be 4. For 2 it would be 4. Okay. So we are to take the differentiation of y with x. means at a particular point we are to take the slope of that point. Okay, and the angle it makes, because dy by dx is written as tan theta, which is the slope of the curve. So first we need to understand the limit of a function. For example, limit x reaching 0 yx. This would entail x to be reached 0, and it can reach 0 from any side. From positive side this would be 0 plus, from negative side this would be 0 minus, and you don't need to know all this. This is just a basic, and we can write it as 0 because this is x square. So even if x approaches 0, y will approach 0 because of this curve. Okay, so limit is very useful in differentiation, because this is the basis of differentiation. So for example, if we are to take differential of y with respect to x, so the standard formula for this is limit h reach 0 f of x plus h minus f of x divided by h. Now you put this expression of y into the right hand side. We have limit h reaching 0 x plus h whole square minus x square by h. This is h. So we have here x square plus h square plus 2hx minus x square by h. This would cancel out, and this would also cancel out. So limit h reaching 0. So dy by dx would be equal to limit h reaching 0 h plus 2x. And this h actually is a very finite interval. For example, say this is a point x. This is a point x plus h. This is a very finite interval h, and it will tend to be 0 because this is an infinitesimal value. Okay, so when h reaches 0, we can easily see dy by dx to be equal to 2x, which is a standard formula for differentiation. Even if anyone applies for xn, we have dy dx of xn, this would be equal to nxn minus 1. So we put 2 here, 2x 2 minus 1 is equal to 2x. So just as you have differentiation, which is the limit of difference, we have integration, which is the limit of sum. For example, say we are given a curve. This is the curve, and this is y equal to f of x. Now we have to find out the integration of fx dx from, let's say, a to b. So these are two intervals, a and b. It is essentially, this is y. So y dx is essentially, dx is an infinitesimal element along x-axis. So we take this as dx. This is essentially the area of this strip. Okay, so we have to integrate it. So we take infinite number of strips, okay, with an infinitesimal width, say delta x. Okay, this is delta x, and this would be y1, y2, y3, etc. So we can write this as integral a to b f of x dx. Now this would be equal to y of x1 delta x plus y of x2 delta x plus dot y xn delta x. So we have summation x a to x b y of x delta x. This will have limit delta x tending to 0. This is because this is an infinitesimal interval. This has to reach 0 from every side, okay, so that the whole curve can be taken into account. Okay, so this is essentially the integration. Although it is not required in physics, but I'll give you an example for solving standard problems through this method. The method is called Riemann method, and in this method we can integrate by using limits. So in Riemann's method we have this equals limit n reaching infinity b minus a by n, this is n, summation k goes from 1 to n, we have f xn star. Okay, this is essentially the Riemann method for solving any integration with limits. Okay, this xn star is given as a plus b minus a by n into k. Okay, so let's take up an example here. Let us suppose y of x equals x square. Okay, so this is particularly the graph. We take the first quadrant only, so we see we can divide this into small number of steps. Okay, so from, let's say the integration from 0 to 2. How do we do it? X squared dx, standard method. 0 to 2 would be equal to x cubed by 3. Taking limits, this would be 8 by 3. This is because x and dx by standard methods is x n plus 1 by n plus 1. Okay, just put 2 over here, you get x cubed by 3 and limits 0 to 2. Okay, and here equal to 2. Now we solve by Riemann method, which is the original method. So we have integration 0 to 2 x squared dx. This would be equal to limit n reaching infinity b minus a by n. Okay, summation k equal to 1 to n. So we would have f of 2k by n. Okay, now why b, actually this would be 2k. I'll tell you why. Because b here is 2, a here is 0. So b minus a would be equal to 2 by n, limit n reaching infinity, summation k equal to 1 to n, and then f of x star it was, right? So xn star we earlier derived as a plus b minus a by n into k. So a here is 0, okay, b here is 2, okay. So this would be 2, this would be 0, so 2 by n, 2k by n. Okay, this is xn star essentially. This so actually we have the final expression as limit n reaching infinity 2 over n, limit k equal to 1 to n, f of 2k by n. Okay, so here f of x was x square, so we can just substitute in place of x, we can substitute 2k by n. Okay, so this would amount to limit n reaching infinity 2 over n, summation k equal to 1 to n 2k by n whole square. Okay, so we can further solve it. 2 by n, summation k equal to 1 to n 4 by n square dot k square. We take this outside, and as it does not depend on the expression, since summation is purely dependent on k, it's purely in terms of k, so we have 8 over n cube, summation k equal to 1 to n and k square, limit n reaching infinity. So k goes from 1 to n. Okay, this would amount to 8 over n cube, and the summation of k square would be equal to from 1 to n, then it would yield n into n plus 1. Basic summation it is by 6. Okay, so this would in the end yield limit n reaching infinity 8 by 3 plus 4 by n plus 4 by 3n square. Okay, so we can easily see when n reaches infinity, these two terms become 0, and the answer is 8 by 3. So guys, this was just to explain you, and you should know this. Actually, it is not relevant in physics, but you should know the basis of these two, integration and differentiation. So I'll give you just standard formulas. D by dx of x of n is always equal to nx n minus 1. Okay, this is a standard formula. All right. And n here is 1, 2, 3, whatever. And the standard formula for integration is x n dx. This is equal to x n plus 1 by n plus 1. Now we will add constant if limit is not there. Okay, if limit is there, constant will not be added, but if limit is not there, constant has to be added. This is the rule of integration. Okay, so guys, I have covered the most basic part. Okay, I hope you liked the video. If you did, please push the like button and please subscribe to my channel. I'll be posting more videos. I'll cover right from start to the end. I'll not leave anything, and I'll make you perfect in physics. Just don't worry. Thank you very much.